Hey there, science fans! Today we're diving into the exciting world of motion with Newton's laws. These laws are like the rule book for how things move, and they're named after the brilliant Sir Isaac Newton. Our first law is all about inertia, a fundamental concept in physics. It says that an object at rest wants to stay put, resisting any change to its state. Similarly, an object in motion wants to keep moving in a straight line at the same speed, unless acted upon by an external force. It's like when you're on a roller coaster, and it suddenly stops. Your body wants to keep going forward due to inertia. To really see inertia in action, grab a playing card and a coin. This simple experiment will demonstrate the concept clearly. Place the coin on top of the card, then quickly flick the card away. Watch closely as the card moves. What happens? The coin drops straight down. This is because the coin was at rest, and wanted to stay that way, even when the card was flicked out from under it. That's inertia. The coin was at rest, and wanted to stay that way. This principle is at the heart of Newton's first law of motion, illustrating how objects resist changes to their state of motion. Now let's talk about Newton's second law. This fundamental principle of physics is crucial for understanding how objects move and interact with forces. This law tells us how force, mass, and acceleration are all connected. Essentially, it explains the relationship between these three important concepts. The more force you apply to an object, the faster it accelerates. This is why a stronger push results in a quicker movement. Think about pushing a shopping cart. When you push it with more force, it moves faster. An empty cart is easier to push than a full one, right? That's because it has less mass, making it easier to accelerate. That's because the full cart has more mass. The greater the mass, the more force you need to apply to achieve the same acceleration. The formula for Newton's second law is F equals sine ma, which means force equals mass times acceleration. This simple equation is powerful in its implications. So if you want to make something accelerate faster, you need to apply more force or reduce its mass. This principle is evident in many everyday activities. It's like riding your bike. The harder you pedal, the faster you go. This is a perfect example of Newton's second law in action. Get ready for an exciting law. We're diving into the fascinating world of physics. Newton's third law states that for every action, there's an equal and opposite reaction. This fundamental principle is at the heart of many everyday phenomena. Think about jumping on a trampoline. It's a perfect example of this law in action. You push down on the trampoline, which is the action, and the trampoline pushes back up on you with equal force, which is the reaction, sending you flying. This back and forth interaction is what makes trampolines so much fun. Let's try a fun experiment to see this law in action ourselves. Grab a balloon and blow it up without tying it. This simple setup will help us visualize Newton's third law. Now let go of the balloon and watch it fly around the room. Notice how it zips unpredictably. The air rushing out of the balloon, which is the action, creates a force that propels the balloon forward, which is the reaction. This is a clear demonstration of Newton's third law in a fun and engaging way. Cool, right? Section 4. Conclusion. Putting it all together. So there you have it, Newton's three laws of motion, explained in simple terms. They explain how objects move all around us, from the cars on the street to the planets in space and beyond. Understanding these laws helps us design amazing things like rockets, airplanes, and even better roller coasters for fun. Keep exploring, stay curious, and remember, science rules our world.